Hey everybody, this is Larry. This is day 16 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. 1631, Path of Minimum Effort. It is Friday night here. I'm always so tired. I'm always complaining. I don't know. Maybe I just need to take a break. But I actually just got back from rehab. Or from physical therapy, and it is tough. So I've been just kind of struggling a little bit, just tiring and exhausting, and trying to do my maximal effort. So unlike this thing. Anyway, let's take a look at today's farm. So yeah, you are a hiker preparing for an upcoming hike. Oh, I do a lot of hiking. I didn't intro this, but maybe I will add an intro now about me hiking. You can skip forward if you like. One of my random drone videos of me hiking. So you're given heights, a 2D array of size rows times columns, where heights of row column represents the height of the cell. You're situated at the top left cell, and you have to travel to the bottom right cell. Okay, you can go up, down, left, right. I feel like I did this one, but I did it wrong. But maybe it's a similar. But you can go up, down, left, right. That's kind of. I feel like I misread these sometimes, where I just don't think you could go down and right. But I guess in this case they have an example for it. The route's effort is the maximum absolute difference in heights between two consecutive cells of the route or of the route. Return the minimum effort required to travel from the top left cell to the bottom right cell. Okay, I mean I think this is actually actually. There are a couple of things I can think about it. I mean, honestly, the first thing that comes to my mind is dynamic programming. And let me look at the constraints for it. Yeah, I mean, if there are only 10,000 cells, right? So it's, R is equal to 100, C is equal to 100. So there's going to be 10,000 cells, right? And the height only goes up to 10 to the 6. So what's 10 to the 6? 10 to the 6 is a million. I always have an off by one about this. So that's equal to a million, which is of course 10 to the 20, right? Oh, sorry, it's 2 to the 20. I said it, I mean, obviously wrong. But yeah, which means that, and what that means is that if we kind of do like a log based on the 10 of the 6, and this is log base 2, it's going to be 20, say, right? That means if we do binary search, it will be 20 iterations. Each iteration, even if we look at every cell, that would be good with like a breadth first search, depth first search, or union find, right? Like maybe union find is a little bit of an overhead, but either way, it is just what you would call it. Like it is linear, right? It's going to be v plus e, and in this case, e is going to be 4 times v. So that's going to be good enough, and I think that's what I'm going to do. I feel like that makes sense, right? Yeah, I mean, and you could do this in a number of other ways as well, but yeah, I think that's right. And the reason why I have 10 to the 6, which I didn't explain, is because if the biggest number is 10 to the 6 and the smallest number is 1, then the biggest delta is going to be 10 to the 6 minus 1, I suppose. But this is going to be roughly good enough. Yeah. Yeah, I mean, I think that's it. So let's get to it. So left is going to be 1 because that's the... Oh, actually, no, that's not true. It's going to be 0, I suppose, like in this case. So yeah, so the end. So now we're binary searching on the answer, and what we're trying to do here is just figure out the range of the possibility, right? So the smallest answer could be 0. I get this wrong sometimes when I'm not paying attention or when I'm fast forwarding it in my head. So this time I'm glad I did. The biggest answer is going to be 10 to the 6, but for binary search it doesn't really matter generally that much if you grow a little bit bigger. So and you can actually, in theory, you can actually also set up it to be like the max value of the height, but I am not going to worry that much about it if with a few iterations or something like that. But so yeah, like that would actually, even if you times it by 2, it would only create 1 more iteration. So adding 10, I don't know, just kind of easier to deal with off by ones or something like this, right? And this is very the way that I write binary search is very standard to me. I know that there are all these patterns. The way that I think about it is just asking myself questions. The first thing is it's easier to define these constraints if, for me, if they're both inclusive bounds. You may disagree, but that's how I think about it. And because of inclusive bounds, this condition is easy to write, because when your bound becomes one cell or one, your range of possibilities become the range of one number, then then that's your answer, right? So yeah, and then mid, and then if good of mid, then what do we do? Well, if this is a good answer, that means that we're going to try to go a little bit smaller. And since by definition, if the answer is good, then it is inside the bounds, inside the range. So right is equal to mid, else left is equal to mid plus 1, right? And that's basically the idea. And at the end, left is going to be equal to right, so it doesn't really matter what you return. But of course, now we have to write the method good, right? And here, I'm just going to do a breadth first search. You can probably do any particular way you want. This is a I was going to say, I mean, let me think about this for a second. I think I skipped, what I was thinking about is that I think I skipped over a little bit of the proof, which is my fault. Also, do I even need binary search? No, it makes it a little bit easier with the states. Okay. The reason why I'm saying that is because I did actually glazed over this a little bit, so that is my fault. I said it was connected components, but in this particular problem, actually what you want is a path. But it turns out that if a component is connected, then there's going to be a path that goes to it, right? Especially on this is a sort of a planar graph. So, and what I mean by that is that there's no way to kind of, like, there's no path in which, and I mean, I guess you can actually construct one, but it doesn't actually change the effort. And I was going to say there's no path where you kind of want to go backwards, right? Like you go forward and then back in the same cell, or even go in a loop. And you can maybe go in a loop, but then that is factored into the connected components, right? So you in this case, you may not actually get the path, but as long as they're connected, well, if they're connected, then there exists a path, and there's no like funky things where, I don't know, like you get stuck, right? Because you don't have to visit, because you can visit every cell twice, but I don't even think you want to, and because you cannot or you don't want to visit each cell twice, or you don't need to anyway. I guess whether you want to is up to you, because you don't go to the same cell twice. Yeah, any path, any way that this is connected should be okay. So yeah, I think that's right. If it's not right, then well, it's gonna be a sad day later. But all right, yeah. So we start at 0, 0, right? And oh, why did I write it like that? Maybe I have to. This is not always a square, right? Is it? No, even all the examples they give you are squares for some reason. But okay, fine. Right, and then now we just set up each cell to show whether it is done or not. Right, and this is just standard buffer search the way that I'm writing it. I'm set up directions. I guess I'll set it outside. right? And like I said, this is really standard breakfast search, though. Watch me muck it up anyway. I feel like I'm making a lot of silly mistakes lately. Yeah. Maybe I'm getting old. Well, ain't getting any younger. So many parts of me hurts. Yeah. Anyway, and okay, so then now this is the check target part, right? Which is heights of x, y minus heights of nx and y, the absolute value. If this value is less than or equal to target, then this is a good cell. So we go to and that's pretty much it. Right, give it a spin real quick. Hopefully it terminates. Otherwise, maybe I have a silly mistake somewhere. The silly mistake is I forgot to do and not, oops. I have to check that it is. I didn't use the done away. Oh, it looks okay, a little bit better. Am I good? Let's give it a submit. All right, looks good. Huh? I've done this three times before, but the last 2 times I got a wrong answer. Why? Is it like R and C is equal to 1 situation, and I forgot to and I set this to 1 or something like this, something silly maybe. Let's take a look. I'm curious. That is, well, I did get the 1 cell wrong, so I guess that was definitely that. I guess I forgot to put the if. Oh, I put the if statement inside instead of out here. A common mistake that I do as well. I try to be a little better about it. And then the second time I got it wrong, I did the same thing. So same mistake 2 years in a row, but not the 3rd year. So I'm pretty happy. I don't know why this is so much faster today though. Like in terms of running time. Did they just like upgrade the computers or something? And I guess last time I did more about the binary search. Today I'm a little bit. I do talk about it. Yeah, I mean, that's all I have for today. Let me know what you think. I don't think yeah, I mean, this is connect components. I think I've gone over this 4 times. I don't know. You have 3 other videos, so let me know, yeah, what you think about this video. Maybe it's time for me to hang it up and retire from Leetcode videos, because they just keep asking the same problems, and I feel like, I don't know, maybe I'm just in a rough stretch with respect to physically. There's so much pain just from all the silly injuries that I keep on doing. Anyway, let me know what you think about that in the comments. I'll add in a drone video hopefully. If not, then I don't know. So yeah, stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.